Welcome, geometry students, to section 2.4 notes, deductive reasoning. You'll notice that this painting here was inspired by Bob Ross with some happy trees and a happy little sun, some happy clouds. So hopefully we'll happily complete these notes. Let's go ahead and get started. Deductive reasoning. Where do you hear the word deduce? We hear it often with Sherlock Holmes and Watson saying, "What do you deduce, my dear Watson?" That is when you analyze given facts to form a conclusion. Okay, so usually with Sherlock Holmes, it was a crime scene. With mathematics, it will be the information that is presented. Now, there's a couple different laws we need to understand in order to kind of formulate these logical patterns. One of them is the law of detachment. This is actually pretty cool once you put it into practice. And this is essentially the crux of this law. If the hypothesis of a true conditional, okay, keep in mind a conditional that's true is written as this. Well, I mean, any conditional is written like this. Just keep in mind conditional is like this, okay? True conditional is true. This is very important, this little arrow. This little arrow is showing that if the hypothesis is true, then the conclusion is, any guesses? Also true. Okay, so if we have a true conditional with a true hypothesis, then the conclusion is going to be true. And that seems to make sense, and once we put it into practice, you're going to see why that's the case. So if P then Q, that's our conditional, is true. So true conditional right here, true conditional. So if that's true, if the hypothesis is true, so and P is true. We'll put it here on the left. If P is true, so that's our hypothesis. If that's also true, then our conclusion is true, just as we said. So our conclusion is also going to be true. This is very abstract with just letters and arrows. Let's kind of give it an example and maybe we'll understand it a little bit better. If a student, so here's our conditional statement. First, we got to figure out if it's true. If a student gets an A on a final exam, then the student will pass the course. Okay, let's just assume that this is true, that for this particular school or course, that's how it works. Second statement, Felicia got an A on her history final exam. Okay, now, anytime we have detachment, we need like two statements like this. Notice how one is a conditional. Okay, as we said, we need a true conditional. And then one is just a second statement. Okay, and we're going to look at that a little bit more closely first. Here's our process. Identify hypothesis and conclusion of conditional. So the hypothesis is the part following if. The conclusion is the part following then. So I have my P, then I have my Q. All right. Step one, complete. We found our hypothesis and conclusion. Check. Does second statement match the hypothesis? All right, so now we need to look at the second statement. Does this, Felicia got an A on her history final exam, match the hypothesis? Okay, does it coincide with this? Is it saying essentially the same thing? And the answer is yes. So it does. Now, why does it? Felicia got an A on her history final exam. A student gets an A on a final exam. Usually these simply provide more detail. So this is just including, it's with more detail. It's not just a student, it's Felicia. It's not just a final exam, it's a history final exam. So it's saying the same thing. It's just providing a little bit more clues, a little bit more information for us to deduce for the final thing, which is, does second statement match the hypothesis? If that is also true, then we write our true conclusion. Okay, so now we can write our true conclusion. I'm going to get the checkbox ready because we're going to check it. You conclude what? Oh, I forgot to say something. Using details. Okay? Then we write our true conclusion using details, or I should say the details. That'd be a little bit better, wouldn't it? Using the details. What do I mean by the details? Well, we just talked about it. Felicia is the student, and the final exam is for history. So we need to include that in our conclusion because it needs to match that second statement. So this is technically our third statement. This is our conclusion. We conclude the student will pass the course. Well, we know who the student is. It's Felicia will pass, we'll say her history course, because it's not just any course, it's her history course. We learn that detail in the second statement, so we need to include that in our conclusion checkbox. Okay? Felicia did well. She got an A on her history final exam. She will not need to retake that class. So that teacher is going to be saying bye, Felicia, when she leaves on the last day of school. Example 2, if two angles have a sum of 90, then they are complementary. This is an if-then statement. This is our conditional. We have a second statement. So this is our conditional, C-O-N-D, period, abbreviation. We have our second statement here. Second, I'm just going to write second. Angle A and angle B add together to 90 degrees. Okay, let's follow the step-by-step process. Identify hypothesis and conclusion. Two angles have a sum of 90. They are complementary. There's my hypothesis. There's my conclusion. Now we need to look at this second statement. Does it match my hypothesis? Two angles have a sum of 90. Angle A and angle B add together to 90 degrees. It's saying the same thing. It's saying it a little bit differently, but add together in sum is the same thing. Two angles is the same thing as angle A and angle B, okay? It's just giving a little bit more detail like we talked about earlier. So yes, it does. We have our second step complete. Now the third step is we can write a true conclusion using the details. So we can say angle A, we're writing the conclusion. So let's use blue. Angle A and, I changed my and look, angle B are complementary. Okay, I'd simply write the conclusion with the new details to form my conclusion. Okay. Example 3, if two angles are adjacent, then they share a common vertex. Angle 1 and angle 2 share a common vertex. Okay, hypothesis, conclusion is first, step 1. Hypothesis, boom, two angles are adjacent. Conclusion, boom, they share a common vertex. Second statement, moving on. Does my second statement match my hypothesis? Let's underline it. Angle 1 and angle 2 share a common vertex. So often people neglect this second step. You really need to look closely here to see if this second statement, separated by a period, that's why I know this is the second statement, does it match my hypothesis? No, it doesn't. Notice how two angles are adjacent, and this one is saying 1 and 2 share a common vertex. This is matching the conclusion. So this, let me use purple. This matches conclusion, therefore, we can make no conclusion about this. And the reason, whoops, not question mark, exclamation point, no conclusion. And the reason why we can't make a conclusion is because there's a different way that we could orient this. Let me show you. So the first thing is saying if two angles are adjacent, then they share a common vertex. Okay, so let's draw what's going on here. Here we have adjacent angles. They're sharing a common vertex and they're right next to each other. Okay? These are adjacent angles. Now, angle 1 and 2 share a common vertex. Now, if it doesn't say it's adjacent, we could draw something completely different. We could draw vertical angles. See how we could make, whoops, let me make this 1 and 2. We could make 1 here and we could make 2 here. And they share a common vertex, but they are not adjacent. So we can't say that they are adjacent when there's a possibility that they're not if they're vertical angles. So we have to follow the rules that's in order for a reason that needs to match the hypothesis first, Therefore, you can draw a true conclusion, but in this case, we cannot. Okay, using the law of syllogism. So law of syllogism is all about a sequence of events. So the sequence of events is like this. If P then Q is true, and Q then R is true, then P then R is true. Think of this as like connecting two true conditional statements that use one of the conclusion becomes the hypothesis of the other. So law of syllogism uses two true conditional statements where the Q of 1, actually it's 3 statements, right? So it's the Q of 1, yeah, that's true, becomes the hypothesis of the second. Then we can connect. Sorry for the notes. Notes are kind of boring. If you want to just skip over me talking and writing slowly, I would do that. Can connect the first P to the second conclusion, which is R. Okay. So this is like kind of like the third statement we can write from the two previous conditional statements. And this is going to be true. You use this all the time. Syllogism you use all the time and you probably don't even realize it, okay? The best way to learn this is through an example, so let's go ahead and get started on that. If it is July, then you are on summer vacation. If you're on summer vacation, then how about this? You work weekends. You conclude what? What do you conclude? If it is July, then you work weekends. This is essentially just a logical flow. If certain things happen, there's like a domino effect. Other things have to take place. So this would be our P arrow Q. Okay, that was true. Let's just assume it to be true. Then we had comma Q arrow R. That was our second conditional statement. And because this is the key here, these need to match. This conclusion needs to be that hypothesis. Okay, that has to happen. And if that happens, then essentially you can bridge the gap here and connect these two ideas, which is what you do with that last statement. So P arrow R. And that's what we did here. Is we took this because it bridges it, and we can write a new statement that's also true. If a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has 4 sides. It's very important that you identify hypothesis, conclusion, second conclusion, because if it doesn't match, then you can't make a true third conditional statement. So if a figure is a square, then the figure is a rectangle. The hypothesis for the second conditional is a figure is a rectangle, so it matches the conclusion of the other one. Therefore, we can bridge it. And I don't mean like a girl's name Bridget. I mean like bridge the gap there. And we can write, if a figure is a square, I'm going to use green, then the figure has 4 sides. And that's a true statement because it has to be. If we followed the logical flow, then there's no way for it to be wrong. That concludes 2.4. Hope you learned something today. Again, the practice and the examples is the best way to learn this. Hope you enjoyed it. Thanks for watching. See you next time on West Explains Best. Try to end on the picture there. Look at that picture.